Hi everyone, this is your math guru. In this video, I'm going to show you how to match the following quadratic function with its graph. A quick recap, using the vertex form of my quadratic function, I have a y equals a in bracket x minus p all squared plus q. What this means is the value of a determines the shape of the graph. That is, if the a is greater than 0, or if it's a positive value, then my graph will be concave up as shown, or a smiley face. If the value of a is negative or less than 0, then my graph will be concave down, or a sad face. P value determines my horizontal shift, and my Q value determines my vertical shift. So going back to the first equation, I have g of x equals negative in bracket x minus 2 all squared. So interpreting each value, I start with my a. The value of a in this graph is equal to negative 1, and what that means is a is less than 0. And once the value of a is less than 0, that means my graph will be a sad face or concave down as it is. The value of p is equal to 2, and what that means is I have an horizontal shift 2 units to the right. Note that I'm comparing my function to the standard vertex form of my quadratic function, and then going to the value of q. Note that I don't have anything written after my bracket, and what that means is there's a plus, an invisible plus 0 that you have here, and the interpretation is the value of q is 0, therefore there is no vertical shift. So going to my graph, obviously it's not going to be the middle graph because that's a smiley face or concave up, so I need to work with the first and the last graph. The second statement says p is 2, so that means horizontal shift 2 units to the right. You can see that the first graph has shifted. That is my origin, that's negative 1, negative 2. It has shifted 2 units to the left. That's my turning point. I can write my turning point. I'm going to add that to my interpretation. My TP, or turning point for this graph, I'm going to write that out. That is 2 and 0. And if we look at my turning point here, for the first graph, the turning point will be negative 2, and then it has shifted 2 units down and negative 2. So what that means is it's not going to be the first graph. Therefore, I'm going to go to the last graph. Using the turning point, I've moved, this is the origin, that's 1 and 2. So 2 units to the right, the x value is 2, and because it's sitting on the x-axis, the y value is 0, which is what I have. So therefore, the first function will be matched with the last graph as shown. Let's look at the interpretation of the other graphs or the other function. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. For the second function, we start with the value of a. We have a equals to 1, and what that means is the value of a is greater than 0. Therefore, my graph will be concave up. The second interpretation is my p value. My p is equal to 2, and what that means is I have a horizontal shift 2 units to the right. And then for this function, if you look at the vertex form, which is the plus q at the end, which signifies a vertical shift, I have a plus 2 at the end there, and what that means is the value of q is positive 2, and therefore I have a vertical shift. Because it's positive, I have that as 2 units down. Therefore, I can write my turning point I'm going to abbreviate that as TP will be minus P Q. Therefore, my turning point here will be 2, and then my Q is also 2. So if I go back to the graph, because it's a happy face or concave up, I'm not going to use the first graph. I've picked the last graph, but I'm still going to say it can be the last graph because they're both concave down. So the next step is to confirm if it's the middle graph using the turning point. So if I check what my turning point is, this is my origin. This is 1, 2, 3. I'm trying to label my axis. Likewise, for my y-axis, I have 1, 2, 3. You can see that my turning point here is at point 2, 2, which is what I have in my interpretation. So what that means is the second function b is the middle graph. And for my last but not the least function, I have the value of a. A is -1. Because my a is -1, that means my a is less than 0. So my graph will be concave down, or its third face as shown. The second interpretation is the value of p. P in this case, as you can see from my standard equation, which is -p, what that means is the value of p here will be -2. So I have p equals -2, and what that means, or the interpretation is, I have my horizontal shift 2 units to the left. And for my q value, my q, if I go back to the equation, is -p. So therefore, q is -p, and then my graph has shifted vertically 2 units because it's negative, 2 units down. Then I can write my turning point. I'm going to abbreviate that. My TP, which is minus PQ, will be -2, -2, as shown. If I go back to the diagram, I need to find the turning point of the last graph. Note that the graph can either be, because there's a set face between the first graph or the last graph, but I'm going to do a double check with my first graph. I have my origin 0, -1, -2, -3, therefore is sitting on the -2 value of my x-axis. And if I go to my y-axis, it's also sitting on the -2 of my y-axis. So my turning point here is -2, -2. So what that means is the last but not the least graph will be matched to the last but not the least function as shown. Thanks for watching. Bye.